Hello, everybody. Today I'm going to be talking about some of our angle relationships in parallel lines, and specifically when parallel lines are cut by a transversal. If you're following along with our stuff in our virtual book or our hard copy book, we're doing stuff in 11.1. Okay, so there's some different vocab and different stuff we're going to talk about, but this diagram that I have here, this diagram we're going to use a lot. Okay, and there's a lot of different stuff that goes on with this diagram, and you'll see a little bit more of it as we go, but there's a lot. So after you watch this video, please go on and do the assignment on Alex. That's about the same type of problems that we're going to talk about right now. So if you look, we have two parallel lines and they're cut by a transversal. So you can see that these parallel lines are parallel. They have these two arrows here on them. Okay, so these two lines are parallel, and this line up here is called a transversal. Okay, for a transversal, it doesn't have to have the same slope, doesn't have to do anything the same, but these two red parallel lines are never going to touch. They're going to go on forever. And this transversal, if it cuts through them like this, it makes all these different angles. It makes four angles up here, and it makes four angles down here. So now we have 1, 2, 3, 4, 5, 6, 7, 8 angles made when this transversal comes and cuts through these parallel lines. So a transversal cuts through parallel lines. Now, with these 8 angles that it makes, we have angle 1, which is just inside right here, this angle. I'm not a perfect artiste. Angle 2 makes this angle. You can see these two angles are different. This one's an acute angle, it's a lot smaller, and so cute. And then this one's an obtuse angle, it's a lot bigger. Okay. What we have to remember that with these transversals and these parallel lines, when we have them come through and cut and make these angles, they're only making two different angle measurements. There's only going to be two different angle measurements. All 8 of these angles only use two different measurements. So a lot of them are going to be equal, and a lot of them are going to be congruent. So if we look, I'm going to start pairing up some of these that are matching. So angle 1 here, this first angle, this angle is going to be paired up and matched and congruent, equal in measurement to 3 other angles. And we have to look at these different angles and see where they kind of match up and why. So angle 1 here can also be the same match for 3 different angles. Sometimes people draw them like this with an arc, and I try to use the same color even when I'm doing this in person to make it easy to remember which ones match. So this one arc in red goes for angle 1. So anything else I put a one red arc on will be equal to angle 1. Whereas for angle 2, I'm going to put 2 purple arcs. Okay, so we know which ones are equal. 2 and 1 are not equal, but 1 and 4 are. They're called vertical angles. Vertical angles are these opposite angles. 1 is opposite of 4, 4 is opposite of 1, so these are congruent. Now, if we look down at the bottom, down here, 5, 6, 7, and 8, there's also going to be some other red angles down there that are congruent. So if angle 1 is red, angle 5 is also going to be red. And these are called corresponding angles. If you notice, they're in the same position. They're 5 at this intersection is at the top left, and at this intersection, 1 is at the top left. So these are both in the top left position, so these are both going to be equal. If you look, you can see that for angle 2, a corresponding angle, this is in the top right, this is in the top right for 6. So that means 6 and 2 are equal. They're corresponding congruent angles. Now, if you notice, once we did that, if 1 and 4 were vertical angles, 5 and 8 should also be vertical angles. So we know that 5 and 8 are equal because these are vertical angles. from what we said. Same reason between 1 and 4. Now, with 8 and 4, you can see they're also in corresponding positions. Bottom right, bottom right. And if I fill in these vertical angles for 6 and for 2, I can also see that 2 and 3 are equal, and 6 and 7 are equal. So now we have 4 groups. We have, or sorry, not 4 groups. We have 2 groups of 4. So we have a red group and a purple group. The red group has angles 1, 4, 5, and 8. The purple group has angles 2, 3, 6, and 7. All the angles in 2, 3, 6, and 7 are all equal. All the purple angles are equal, and all the red angles are equal. No matter what angle measurement number 1 is, it could be 5 degrees, it could be 100 degrees, it could be 200 degrees, it could be 6 degrees, 7 degrees, 59.3 degrees, all the other red angles will match. So what I'm going to do is, if I give an angle measurement to number 1, let's say number 1 is 70 degrees. If angle 1 is 70 degrees, and they usually put a little 0 there, degrees, just kind of like it's a temperature, 70 degrees. So if this is 70 degrees for this angle measurement in red here, then I can go to all these other red angles for 70 degrees. 70 degrees. And now if I go to the purple angle measurements, I can find out how much those are. And they're going to be equal to everything. So if I know that angle 1 is 70, well, then I know that angle 2 is going to be 180 minus 70. And that gives me there we go, 110. So now 110 is my angle measurement for these purple angles. And that matches with 2, 3, 6, and 7. So now all my purple angles are 110 degrees. What you might be thinking is, Mr. Copeland, what was all this? How did you know 180? Where'd you get that number from? I haven't explained that yet. I'm going to explain it right now. 180 is a very, very important number for these problems, and also some new ones we're going to do in a little bit as well on the next couple assignments. In this unit that we're talking about, 180 is a very important number. So we're going to have to remember that. So why did I use 180? So I used 180 because 180 is the number for supplementary angles. 180 degrees is for supplementary angles. That means a straight line, the measurement for a straight line, if I made this straight line here, oh, not very straight. Way better, right? Right? I can't hear any of what you're saying, so I'm assuming all my students right now are saying, yes, Mr. Copeland, that looks beautiful. So if this angle measurement is 180 degrees, because every straight line is always equal to 180 degrees, then that means angle 1 and angle 2 together make one big purple angle, make this one purple straight line. It is 180 degrees. So then that means that angle 1, this half, and angle 2 on this half, these two together must make 180. So whatever the green, whatever the green angle measurement is for angle 1, or whatever the orange measurement for for angle 2 is they must add up together to make 180. So angle 1 plus angle 2 equals 180. If you know whatever angle 1 is, then angle 1 plus something makes 180. In the problem I did earlier, I had 70. So I knew that 70 plus 110 makes 180. And I could subtract if I wanted to. 180 minus 70 makes 110. So with these two numbers here, if you look, they have this symbol. It's like this little triangle. It's kind of like a triangle, but it's missing a side. It's just supposed to be one angle. And you read this as angle 1, angle 2. So angle 1 plus angle 2 equals 180. For every single straight line that's out there, it'll always be 180. So I'm going to do a little bit more work on another diagram. And if you look, and if you notice, this is the same type of diagram. It's just kind of turned around differently. We still have two parallel lines, and we have one transversal cutting through, and we've made 8 different angles. No matter if this is turned around or upside down, the same properties still exist. 180 is still a really important number that we'll use, and all of these angle measurements are going to match. So if I look, angle 1 is going to match with angle 4. Those are in opposite spots. So angle 5 and angle 8. These vertical angles correspond with these vertical angles. 1 and 4 are equal, 5 and 8 are equal. I don't know what the number is yet. I haven't put a number for the angle measurement, but I know that they're going to be equal. I'm going to grab my purple, and I'm going to say angle 3 is going to be purple, and angle 2 must be congruent then, which means 6 and 7 are in corresponding spots. A lot of these problems are just looking at the diagram and seeing where these angles match, looking for the angles that are in the same spots to match up the ones to be purple, the ones to be red. So now, if I say that my angle measurement for number 1 is, let's say it's 50. So if angle 1 is 50 degrees, then I know that all these other red angles are 50 degrees. Bam, now I got 50 degrees. Now I got to figure out my purple ones. Well, if I know that this one is going to be 50, then what I'm going to need to do is I'm going to need to do 180 minus 50. And if I figure this out, some of you might have already done it in your head, and you might already be yelling at the computer screen, Mr. Copeland, it's 130. Well, I double checked it, and it's 130. Because now, if I add 130 plus 50, it gets me right back to 180. So now all these purple angles, no matter which one or which position, they're all going to be congruent to 130. Now I have 130 at all these purple angles. So what you're going to be doing on this assignment is just this. They're going to give you a setup, a diagram, and they're going to ask you which angles are congruent, which angles might be different. And if they give you one angle measurement, you can then find all the other 7. There's 8 total. If they give you one, you can find the others. I'm going to go through one of those problems right now, and they're actually not going to even ask you for every angle, just a couple of them. So if I take a problem like you're going to see on Alex, it's going to look something like this. And it's going to give you angle 3, 107. And it's going to ask you to find angle 6 and angle 8. Okay, so if we know, let me see if I can zoom in on this a little bit. Oh, there we go. So if we know that angle 3 is 107, then we can find out which ones match that and which ones we might need to subtract with. So if angle 3 is red, then which other ones match it? Well, we can go through and label all of them if you want. like angle 1, angle 5, and angle 7 are all going to be red. But do we really need to go through every single one? No, we just need to go through the ones that we're looking for. We're looking for angle 6 and 8. So if we go down here, we can see, well, all these red angles are 108. Then that means all the other angles must be a different measurement. And we're going to need to subtract from 180. All right, 6 and 8 are what we're looking for. So those must be the other colors. Those must be the purple ones. All right, so now I'm going to do my math, and 180 minus 107, because that's the red angle measurement. The purple angle measurement is when I subtract this. So now 180 minus 107 is going to be 73. So now all these purple angles are going to be 73. 73. And 6 and 8 are what they're asking for, so that's going to be 73 degrees. When you type this in, you're going to have a little box here to put the answer, and it's going to ask you to type in 73 for 6 and 73 for 8. Sometimes they're going to mix it up. Sometimes they'll ask for different numbers. Sometimes they'll ask for different angles. Sometimes they'll ask for 6 and 8. Sometimes they'll ask for 3 and 4. Sometimes they'll give you 3. Sometimes they'll give you 2 or 7 or 5. Those things will mix up. This diagram might turn and rotate and change, but it's still going to be the same properties.